what you call, when we load the data into the data warehouse, we actually load the data, and once the data is loaded into the warehouse, it will never be deleted. That was the statement, right? So we are all in the impression that okay, once the data entered into the data warehouse, it will never be deleted. But you know what? Sometimes in very rare cases, there might be a situation that you have loaded wrong data into the data warehouse. And let's say there is no way of correcting it in the data warehouse. Right? So then what would you do usually? If given a chance, what would you do?
Can we update the data, Raj?
Yeah, that's the problem. So even though we update it, it is not going to be correct because the data itself is wrong. So let's say there are some orders that were order details that were sent to me by some person, some client. Those order details were wrong actually. So he sent me the wrong file, and I don't know whether it is wrong or right because I am a technical guy. What I do is, whatever the file he sent me, I just load it into the data warehouse. Then after that, he's saying, okay, so I sent you the wrong data, so I'm going to send you the new data. So what would you do with the old data?
So there is no chance of dropping the table in the data warehouse and then creating a new one?
No. Don't even think about dropping a table in data warehouse because only whatever the data he sent last month is wrong. But for all these years, the data is there, right?
Okay.
So we should not drop the table. If we drop the table, all the previous data will be gone, and the table itself will be gone.
Okay.
Yeah, so in those cases, we will delete the data from the table. So, and we carefully delete only whatever is the wrong data. So if you say truncate table, every record in a table will be gone, right? I mean, if in a table there are 1 million records, and if you say truncate table name, and then every record in that table will be gone. But if you say delete from so-and-so table where these are the order numbers or delete the data for this month which came from a file. So this kind of queries, if you write and carefully delete it, that's called data purging. So data purging may be required in some cases where a wrong data is entered into the data warehouse, and then that wrong data cannot be corrected in any known way. Technically, it may not be possible. In those situations, what we do is we will delete the previously loaded incorrect data, only the incorrect data, not everything, and then reload it. So the deleting part is called purging. So you will permanently delete the wrong data, the incorrect data that was loaded into the warehouse carefully, and then reload the data. So this is called data purging. So data purging is kind of like removal of sensitive data from a system or a storage device with the intent that the data cannot be reconstructed by any known technique. And I gave you the real-time example. The real-time example is usually what we get is like I said, for a data warehouse, we might have multiple users. Like is shown in the picture. So for a data warehouse, database, the data might be coming from different data sources. The OLTP, data sources, files. So let's say the client is actually maintaining the booked orders in this database. But some orders he is entering into some file because those orders are not processed through this system. So he is maintaining them in a separate file and sending it to us. So let's say I will get 100 orders information from this database, which I will load into the data warehouse. And from here, he sent me another 20 orders. So usually, this is the process every month. Let us say every month he sends me some orders through file, and every day I am going to load the orders information from this database, OLTP database, to the data warehouse. So this I am loading daily, but this I am loading only when he sends me the file. So every month he is regularly sending me the file, and in 1 month, in one of the months file that he sent, he mistakenly entered the wrong data, and I don't know that, so I loaded it into the warehouse. And later on he comes back and says, okay, I sent you the wrong file, or data in that file is not correct. So please remove everything that I sent you only in that file and reload this with the new file. And then he sends a new file. Did you understand the situation? The scenario here?
So, yeah.
Yeah. So when that is the case, then there is no other choice for us than delete the data from the database. Yeah. So in general, purging or sanitizing is the removal of sensitive data that is stored in a database or a storage device, with the intent that the data cannot be reconstructed or corrected by any known technique. So, as an ETL developer, as an ETL person, so you have to do the data purging from the data warehouse. Data mining. Let's talk about data mining. So far we have been talking about data extraction. So data extraction meaning extracting the data from the data sources. So here the data sources are OLTP databases or some files. So the data extraction is the process of extracting the data from these databases, OLTP databases or files. And data transformation is nothing but manipulating the data as per the business requirements, manipulating the extracted data from the OLTP data sources or files and transforming it as per the business requirements and then loading it into the warehouse. This is complete process is called ETL. So here extraction stands for data extraction, transformation is data transformation, and loading is data loading. Okay, so far we have been dealing up to data warehouse. So what's beyond data warehouse? Beyond data warehouse is nothing but reporting, right? So once the data from all these OLTP data sources and files goes into the data warehouse database, then we need to show that information to the end users. And what does end users do with that information? So that's the question here. So the end users use that useful information and identifies the trends in the business. And in general, the reporting happens like they'll have an idea about, okay, what is the total revenue in this month, or what are the total number of orders in this month, or what is the total quantity that they may have to deliver in a particular month or in a particular year, so on and so forth. So basically, they analyze what has happened. Data mining is essentially not only just knowing what has happened. See, if you just say reporting, okay, that means you are just talking about, okay, how much is the total revenue in this particular quarter or in this particular year, in this particular month. Means you are talking about the things that have already happened. So based on those information, you are coming to like, let's say you have booked 3 orders in the month of March. So you're saying, okay, I have total count of 3 orders and I've got $1,000 revenue. So that's the revenue for this month for you. But that has already happened. Data mining is essentially not only just knowing what has happened, but it will also include predicting the future. Based on the existing data, you will do some deep analysis of the data and predict the future trends. So you say, okay, in future, in the next quarter or in the next year, 1 year, the sales of so and so products is going to be up, or the business trend is going to be like this, and then you will put it in a chart. Like if you see any stock exchange graph, right? So it will move up and down and so on and so forth, right? So similarly, you will do some trends prediction, trending basically, right? So data mining involves these kind of things. Not only analyzing the data based on what has happened, but it includes also future prediction, forecasting of the business trends, how it is going to be, and expected, let's say, forecasted revenue, forecasted number of orders, anything that matters to the business. So data mining is a very popular technique. But you know what? It is more of a reporting. Like I said, data mining is done by using any reporting tool like OBIE or Cognos, whatever. But the data mining will be done based on the data in the data warehouse usually. So as an ETL guy, we fetch data from every nook and corner in the organization and load into the data warehouse. And once the data is available in one single database, and that will be the platform for all the reporting and analysis purposes as well as data mining purposes. Data mining is nothing but utilizing the existing data and doing a very deep analysis, which might help us to predict the future trends, current and future trends. So that's why data mining is done usually after the data warehouse is built, and it's a very popular technique to understand what has happened in the business and what is going to happen in the business.
So Raj, so basically, like data mining is like something making the data more relevant to the business.
No, actually, utilizing it more for the future analysis purposes. Actually, if you say simply reporting, in the reporting you will just usually do some very simple analysis of data, like how much is the total revenue, how much is the total number of employees. This kind of simple analysis you do. That's reporting. Essentially, reporting will let you know. Reporting will let you know what exactly happened, what has happened, right? But when it comes to data mining, it is going in deep, digging more into the data, the same data, but will be analyzed more closely, and then you link something to something within the data warehouse, and then you say, okay, so since this is happening with this, the future is forecasting would be this. So there are so many tools to predict future trends and behaviors based on the existing data. See, just to keep it simple, reporting is high-level analyzing of data, but data mining is digging more into the data available to get a deep understanding of it, which might help us in predicting the future trends. So, for example, let's say, when would be the usual sales of ACs will be more? Common question, a generic question.
Summer.
So usually it is in summer. And when will be the sales of sweets will be more? Sweets, I mean, so usually at the time of festival, right?
Festival season.
Yeah, usually at the time of festival season. Yeah. But then, these are all people who, everybody knows it, okay? In summer, air coolers will be more in demand. But how many? So, this data mining, if you dig more deep into the data, based on your past sales data, you might come to a conclusion that, okay, so last year I sold 10,000 ACs. Before that, I sold maybe some 7,000. And before that, it was 4,000. So continuously, there is a 30% rise in the business. So this year, I might target 15,000 or 13,000. Right? So that's called future prediction. So now I have given a rough estimate that maybe this year the demand will be up to 13,000 ACs. And then if we push up the sales aggressively to 10 more percent, so maybe I will sell 14,000. And maybe my sales manager are so aggressive that they want 15,000 ACs to be sold this year. So, but when you came to a conclusion that in future maybe there will be demand of maybe 13 to 14,000 based on your past data. But let's say, what was your sales last year for the ACs? That's the question what reporting answers. So reporting will answer, okay, last year you sold 10,000 ACs. Okay, but that has already happened. When you do data mining, you'll be able to answer, okay, what's going to be sold in let's say, this year? What could be the sales? Some predicting. So based on the existing data, you do more deep analysis of the data and you basically give some future predictions, forecasting, and stuff like that. So let's say, have you ever wondered, if you look at, I'm not sure about how the petrol bunks have stations, filling stations do function in USA. I don't know how the setup, but if you look in India, if you go to any petrol pump here, they have a storage area underground, right? And that will be in front of the filling point. I always wonder, how do they know that the stock is going to end? Because there is no monitoring system as such. Still they are following, like, okay, they put in some some very lengthy sticks, and then based on the how much I mean,
measuring scale, basically.
The scale
depends on the level. They estimate.
Yeah, so అది ఎంతవరకు మునిగిందో చూసుకుని దాన్ని బట్టి వాళ్ళు ఒక ఎస్టిమేషన్ వస్తారు, రైట్? కానీ ఫర్ ఎగ్జాంపుల్ లెట్స్ సే ఎప్పుడు కూడా స్టాక్ అయిపోయిందని నేనైతే చూడాల. అంటే ఎప్పుడన్నా బన్స్ అలాంటప్పుడు తప్పితే ఇన్నేళ్లలో వెరీ రేర్ గా చూస్తాం నో స్టాక్ పెట్రోల్ పంప్స్ లో. వాళ్ళకి అంత కరెక్ట్ ఎలా తెలుసు అంటే, ఓకే మేబీ ఎంత ఉండబోతుంది, లేకపోతే మేబీ మన డిమాండ్ ఎంత ఉంటుంది, ఇంతమంది వస్తారు అని వాళ్ళు ఎలా మెయింటైన్ చేస్తారు?
As of here, Raj, basically what they do is like in the gas stations here, every day or so, every week or so, whatever, the suppliers, they call here in the mornings or whatever, and they ask us to see the measure. Okay. So by giving them the measure, they know like they want to bring the load or something like that. That is what happens here.
Right. So that's where the answer is. So when you call them, they ask you what is the stock there, right? And then you give them some number, and based on that number, they will decide whether to send the stock or not, whether to send the petrol, the gas or not, right?
Yes.
So that means, let's say, if you said, okay, the stock is I have right now 10 liters, for example. they know that minimum there should be at least 20 liters in there based on the demand, right? But if you go and check in any remote areas, do you see the regular supply there as well? I don't think so. Regularly they may not supply that much to them. But for some reason they came to a conclusion, at least we need this much, the minimum storage, right? So that's called quantitative method. So they analyzed based on the figures of the past. They did some calculations, they did some data mining and came to an, okay, so every day or at any given point of time, this is the minimum safe betting, minimum stock that we need to maintain in order to meet the demand. So it's very critical. Like if you don't meet the demand, supply and demand does not balance, then you're going to lose out in the business. Not only petrol pumps, right? So anything else. So let's say the people who doesn't know. Let's say the summer is upcoming in India. It has already started, right? Now everybody knows that AC is going to be in demand. Air coolers, I don't know, maybe refrigerators as well. So when companies cannot estimate how much would be the sales, and let's say they produce only around 10 to 12,000 of ACs, and in the scenario that I was giving, and then let's say the actual demand came to around 14,000. So that means there is a lack of around 2,000 ACs. So there is a lack in supply, even though the demand is there. So the business will be lost, right? So you will be losing some businesses. But data mining helps in avoiding those kind of things and gives us a deeper understanding of what is happening in the business. And it will also let us know some kind of unpredicted trends. Let's say everybody knows that in festival season sweets will be sold. In summer air coolers will be sold. But maybe these days if you see the trends, they are announcing so many offers on Independence Days, especially on the holidays, weekends, they are announcing special offers. Because they know over the weekends people will buy. But they are actually analyzing the trends. These weekend offers and all, I never saw it in the childhood, or even I didn't saw in my college days. But in the last, if you look at the last 4 or 5 years, or maybe last 3 years in India, the weekend offers have actually they've gone up like anything. Like everybody, every shop, every store has a weekend offer. Of course, they do charge more than what they usually charge on the weekdays, and then they say, okay, this is the discount. But then usually it is the same price. But the trending has changed. That people know, companies understood that people are shopping more on weekends, and then they started offering more, attracting more customers. And then they want to also encourage the sales. They know how to attract the people who are doing window shopping. So that's why they introduced a new trend of announcing the discounts and stuff on the spot. So if you just go in, roaming around any shopping malls, these days I'm observing that not only these days, like from the last 4 or 5 years, all the big malls, if you go in and just go for a window shopping, they will give you some tempting offers and then make you buy something at least. So the trends are so important for a business to keep in this. So let's say I've been teaching Informatica, OB, and blah blah blah, but I don't know when up to what the demand would be. So then we have introduced BAS, and we are now everybody else is also learning BAS. Now we might have to think about introducing in-depth of each analytic module of BAS, like finance, analytics, HR. So every business has to have some training to understand, okay, what's going to be the next step. Reporting will just give you idea about what has happened, but then data mining will let you know what are the usual trends in your business. Basically, it is analyzing more of the existing data and get most out of it. Okay, so data we have discussed enough on it. You don't need dimensional modeling, but let us just briefly discuss about it. Dimensional modeling. So let's say we were talking about the OLTP databases, the files, etc., and then data warehouse, database, and blah blah blah. So who will be designing the tables within a OLTP database? Designing the tables meaning who is going to decide on what table should be there in a OLTP database?
Basically, the business user. Or the user actually.
So I'll give you one example. So let's say I ask you to build a reporting system for your college. Where would you begin with actually? So the requirement is that I want to know how many students are there in each department, and then I would also like to know who are the students who frequently use the library facilities, computer lab facilities, and I would like to know the percentage of maybe Indian students within each branch, right? And percentage of part-time working people within each branch. So I want to analyze my student data. What will you do? Basically, first of all, where do you begin with?
Basically, starting with the student ID number.
So first think about, you have to first capture your student data.
Yes.
You have to capture and store your student data somewhere, right? And then you want it to automatically enter as and when the student information gets available. Immediately you enter it, and then you do those regular, what we call transactional type of thing. So you design some automation wherein student details are automatically can be entered by management or by the students himself. By logging into some website, he can fill some form, and then he can enter his details, etc., etc. And then he can opt for a part-time job and whatever. So basically, or let's do one thing. Let's say I asked you to design an online ticket booking system. So where do you begin with actually? Let's say I asked you to design a system which I can use for online ticketing or online ticket booking system. Where do you begin with actually? So for example, I'll show you. So here, this is one of the websites, Class3.com, where we can book the airline tickets, international and domestic. So let's say I want to book a ticket from Hyderabad to New Delhi on so and so date, and let's say click on search flights. I do get some flights, and then I choose one of the flights, and then maybe I want to book it, right? I'll book it, and then while booking it asks me some blah 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 information, and once I make the payment, the ticket will be confirmed, right? So this is how an online booking is working. And when I ask, obviously you know that this information has to be stored somewhere. whatever the information that I give in here should be stored somewhere automatically. Because for companies, it is so critical. Information is so critical, right? So now, just imagine, I enter some information here. Okay, I enter some information here and some blah blah blah, and then continue. Here I give this information and then I make the payment. Where does this information go into?
Table which is associated with the backend.
So basically, maybe one table or multiple tables which are associated with this application, right? So basically, in a OLTP also, the front end will be some application, right? And the back end will be a database. And in the database, the tables will be already designed because your application is predefined, and these forms and all will be associated with the tables, OLTP tables. So that means whoever develops the application is going to decide how many tables do they need in the OLTP system, and in what table what information should be managed. So there might be a customer table, there might be a ticket booking table, there might be some booking history table, right? So different tables, and they know how to join each table with other. So based on the application functionality and all, so that these OLTP tables are actually designed by the application developers itself. So keeping in view of how the whole system is going to work and what information is to be captured where, in which table. So based on that, how many tables might be needed and what would be the relationship between them. So that thing will be actually, is already prefixed. So it doesn't change for every organization to organization. For example, can you let me know the available ERP systems in the market? Popular ERP systems? Anyone? You can type in. Hello? Is the answer clear? Sorry, the question clear? Popular ERP systems. Okay. Have you heard about SAP?
Yes, sir.
SAP, Oracle EBS, PeopleSoft.
Yes.
So these are all ERPs.
Yeah.
Yeah. But then let's say if I buy a SAP for my organization, and if you also buy SAP for your organization, and if you implement SAP, and if I implement SAP, are the tables going to be different for you and me?
Depends on the application, right, Raj?
It depends. Let's say we both purchased SAP HR module, let's say.
Okay.
That means we want to just implement SAP HR for the HR processing purposes.
Okay.
Okay, so the front end will be SAP, wherein through front end I will be processing all the HR records, and then they will be stored in the back end in some OLTP database. But what the question is, like, if you implement SAP HR, then if I implement SAP HR, are the tables in the back end will be different or same?
I guess it may be different.
You know what? They are same. Usually, if you install any software which might create some tables in the background, so those tables are prefixed. Those are application tables, right? So when you install SAP HR in your environment and in my environment, the SAP HR module functionality is same. The way it stores the data is same. The only thing is your business, your information, and my business, my information will be stored. But the way the SAP HR module works is same, and the way it stores the data into the OLTP database is same. The number of tables will be same. everything is actually inbuilt, right? So when you install SAP HR module, the related tables will be automatically created in the system, and that's the case with any ERP system. So you don't see different tables in your environment and my environment, basically. But after implementing the basic module, then you may want to go for some enhancements or some changes within your organization, which are strictly for you. For me, I may go for some other modifications. The enhancements may be different, but the basic stuff will be same. So if you install, for example, when you let us take an example of a database. When you install an Oracle database, you would get some sample schema like HR, SH, and stuff, right? So when you install a database and you get some sample schema, will your HR schema and my HR schema will be different? Let's say we both install, all of us install 10G, the Oracle 10G database, and then we get some sample schema using the database. So are those database tables going to be same or different for all of us? Right? Initially they will be same, but later on you might want to change them based on your requirement. So that's the same case. When you install any application, the backend tables will be same for you and me if we are using the same application, because those tables are already defined. Okay, these are the tables that we need for SAP HR module. So these tables have to be created, and they will be automatically created when you install the software. And the information is to be stored within them only. So for example, in SAP there will be a table, let's say employee table. So whenever I register some new employee, that information will be automatically going to be stored in the employee table. So I don't have to change the process. So this way, the application designers will decide their database model, and that OLTP design is called ER modeling, entity relationship modeling. I'll show you some examples of entity relationship modeling. That should be. Yeah. So this is the entity relationship modeling. So they design, okay, so customer table is going to join with orders table, and orders table will be joining again with items, stock, catalog, blah, blah, blah. So this way, the tables and their structures will already be defined in the backend. Okay. So OLTP databases are designed using a ER modeling technique, entity relationship, wherein they define all the tables, the structures, which are known as entities, right? Tables, entities, and then the relationship between them. Okay, now enough on who decides what will be in OLTP. Let us discuss about who is going to decide about data warehouse. Because definitely now the data warehouse will be completely different for you and me, right? Because I may implement a database or a data warehouse. If I implement, I might choose some data stage, and I might choose to implement data warehouse only for HR data. And in your organization, you might want to implement finance data. For finance data, you may want to implement a data warehouse or a data mart, let's say. Okay. And then you may opt for Informatica. So the tools, the technologies, the way you want to manage the data warehouse is all designed by you. Because there is no common data warehouse, right? Unlike SAP or unlike PeopleSoft or unlike Oracle EPS, we don't have a Oracle data warehouse or SAP data warehouse, this kind of stuff. As let's say, if we don't have something like that, then what's going to happen? Then that means you have to design your own data warehouse. You have to define the table structure, and you have to define the relationship between those tables. What tables are going to be in the data warehouse and what's going to be the relationships between them, right? So how do you design that is the question here. The answer is simple. For data warehouse, what is the tech that we use is dimension modeling. So when you do dimensional modeling, the output of the dimensional modeling will let you know what tables you should have in your data warehouse and what should be the relationship between them and all. So that output will be there when you do the dimensional modeling. So dimensional modeling is nothing but a set of techniques and concepts used in data warehousing design. Okay, this is different from ER modeling. ER modeling is done for OLTP databases, but dimensional modeling is done for data warehousing databases. So dimensional modeling involves a four-step process. So usually, why do we build a data warehouse? We build a data warehouse to store the data, right? We build a data warehouse to store the data. But what kind of data do we want to store here? Whatever is demanded, whatever is asked by the end user. Okay, I want to report against science of data. So in the data warehouse, we provide him with that information. He says, okay, I want to report against my sales data. So what we do is from the existing OLTP system, we extract the sales data and then load it into the data warehouse. So how are you going to maintain that sales data? Because the OLTP tables, their structures, the joins between them, everything will be different. And in data warehouse, the tables, the structures, and how you are going to maintain the data is going to be different. The reason is straightforward. OLTP systems are meant for fast transactional processing. Okay, so basically, when I try to book some ticket, I should be able to finish it off in maybe let's say 2 minutes, not more than that. So OLTP systems are actually meant for supporting faster transaction processing. But data warehouse databases are not meant for that. They are meant for faster analysis of data. I mean, data warehouse databases are meant for analyzing purposes, not for transaction purposes. So analyzing purposes meaning end users want to analyze the data that is available in the data warehouse. That means when you want to analyze the data, what will you do? I mean, let's say if I ask you to log into your database and analyze the employees data that is available in employees table of your HR team, what you usually do? Log into the database and say select star from so and so, right? So usually you log into a database. And then to select star from employees. Okay. And then on top of it, you may want to analyze on top of it. Okay. Select max of salary from employees. Maybe this way. So you do a lot of analysis on the data available in this employees table. So similarly, here, data warehouse is meant for analyzing the data by the end users. So that means if you want to analyze the data, you have to select the data. Selecting the data meaning retrieving the data. So in order to retrieve the data faster, the table structures and all these things does matter, the relationships and all. So the data warehouse purpose is to enable faster analysis processing, whereas OLTP databases are meant for faster transaction processing. Okay, so that's why the purposes of OLTP database is different. The purpose of data warehouse database is different. Data warehouse database main purpose is to enable faster analysis processing, reporting basically. So while designing the data warehouse, we keep it in view of how fast we can retrieve the data from the data warehouse database. In a OLTP database, there will be many number of tables. There will be very huge number of tables, like I might say like thousands. Okay, if you take any ERP system like Oracle, EBS, or SAP, the number of tables will be very huge. Tables here and thousands of tables. And then the relationship between them and all, so that's a very long chain actually. Okay, this table is related to this table and so on and so forth. So in a OLTP system, since the purpose of the OLTP database is to process the transactions faster, they design in such a way. And then since they do process a lot of transactions every day, the redundancy of the data should not be there. There should not be any duplication of data. So basically, they do some normalization technique. They use the normalization technique when designing a OLTP database. But here, for data warehouse, we need to put the data in as many less number of tables as possible. The reason is very simple. If I have 10 tables here, where the required information is stored. So I have to write a query, select blah blah blah, on 10 tables. And when you say 10 tables, usually how many minimum number of join conditions that you might have to give? Do you know this formula? So let's say if I have table A and table B, I have to write some query on table A and table B. What is the minimum number of join conditions that I may have to give? Let's say I have a employees table and also let's say I have department table. So I want to fetch employee's name and the department name. So how many minimum number of join conditions that I have to give here?
One.
So usually the formula is like this. N minus 1 is the formula. So in this case, 2 tables, so 2 minus 1. So minimum number of minimum join conditions is 1, right? So similarly, if I have 10 tables in the OLTP where the required information is there, then how many join conditions I might expect? Minimum of 9, right? So if you have more number of joins, so will the query performance will be faster? And now let me explain a scenario in data warehouse. In data warehouse, out of those 10 tables data, I was able to manage it in let's say 4 tables itself. Okay. So I did not bother about whether the data is repeating and blah blah blah, but I put it in only 4 tables. Right? Now if I have to write a query on the data warehouse, that will include 4 tables. And how many join conditions? Like n minus 1. 3 join conditions will be there. So if you have less number of join conditions, will the query be faster, or if you have more number of join conditions, will that query be faster?
Less number of joins.
So usually it is one with the less number of join conditions, right? So data warehouses are to be designed in such a way. I'll give you one simple example. What makes the difference in designing a OLTP database compared to a OLAP database? I mean the data warehouse database. So while designing the OLTP database, let's say I want to store some customer information like customer ID, customer name, customer, let's say phone number, city, country, state, country, blah blah blah. So let's say I have customer ID 001, customer name some John, phone number, city, let's say Hyderabad, customer state AP, customer country India 002, some RAM, some phone number, city AP. Yeah, if from a single city you can expect multiple customers, right? And let's say some so on and so forth. So I must have so many customers from Hyderabad. Right? This way I may have so many customers. While designing the OLTP, you would definitely love to reduce the redundancy. Here unnecessarily we are repeating, okay, Hyderabad, AP, India, blah blah blah. Instead, what I would make it is, I would prepare two tables. One is customer and one is maybe locations. So in the customers table, I would maintain the customer ID, customer name, customer phone number, and customer location key. So location key I will come to that later. So in the locations table, I will set the location ID, location, city, or maybe we'll just simply city, state, country, etc. Location ID, maybe 1001, city Hyderabad, state AP, country India, right? And here in the customer table, what I would maintain is location key as 1001. Okay, and now for RAM, the location key will be again 1001, and for Wish also the location key will be changed. So here I reduce the redundancy of this data. So I have normalized the data so that the redundancy is reduced. So there is no duplicacy of data in the table. So that for me it will be very simple to manage. But when it comes to data warehousing, I would like to do it in the reverse way, because I want to reduce the less number of joins. I want to reduce the number of tables so that the retrieval of data will be faster. Because if I have to select the country and the customer name, then I don't have to write the query on two tables. Instead, in a data warehouse, if I maintain everything like this on one table, so I will have to just simply say, okay, select country name and customer name from customer's table, so that the retrieval will be faster. So the purposes of both the databases is different. For OLTP database, it is how fast the data can be transacted, and for data warehouse, how fast the data will be retrieved from the database when I write some query. So based on keeping in view these things, we design a data warehouse database and a OLTP database. So for designing the data warehouse database, we use a technique called dimensional modeling. Dimensional modeling is a step process in which first we identify the business process, client's business process. So client, let's say the business says, okay, I want to have a data warehouse for my sales data. So what we'll do is we'll understand how the data, what is the business process of sales for this customer, how he is selling his products. So where is the sales life cycle starting? What is his business process? How is he getting the sales? How is he getting the customers? So all these things, we analyze what are the important things. We first identify and define the client's business process. Client's business process is, he might be having so many processes like HR process, finance process, but he specifically said, okay, I want the data warehouse for my sales process. So when he says sales, we'll concentrate on the sales subject and identify the business process of how the sales happens for a particular customer, for a particular organization. And then once we analyze that process, we identify the important entities in a sales process. So what are the important entities in a sales process? For example, in a sales data, usually what will be the important entities? Just take any sales data, any sales this thing. So what you can do is you can either sell a service or a product. Usually products, that is products. And then sorry,
quantity
and all comes when we really sell it. But let's first identify what are the things that might be important in a sales process. So we can sell products to whom? Customers, right? Where? In which location? Right? At what time? So we have to maintain time. And through which channel? Through which channel? Or how are you going to promote that product? Then comes the sales, actual sales. Who purchased that product? What is the quantity? What is the product? What is the time? What is the location where the purchase? So these kind of things comes under the real sales transaction. But then I was just identifying the important aspects within the sales business. So for me, for now, these are the things that I can just say. Okay. So after identifying all these important business entities, these are called entities. So when we understand the client's business process, we identify the entities and then attach attributes to those entities. Attributes meaning, let's say, okay, I have a product as entity. So what describes the product? Maybe a product ID, product name, product category, product subcategory, product price, etc., etc. Right? All these things will give you more information about product. So these are called attributes. Attributes mean those defined in a particular entity. Right? Here, customers. For customers, maybe customer ID, customer name, customer phone number, etc., etc., which defines a customer. So these are the attributes of customer. Right? So when we identify the client's business process, understand the client's business process, and we document it, and after understanding enough of the business process, we can identify the important entities within that business, and then try to identify the attributes that define those entities, and then attach these attributes to these entities, right? And this forms a table-like structure. Now, if you see, okay, I have identified these are the entities like product, customer, locations, time, channel, promotion. These are the different entities in the business. So I have identified all these important entities, and then I have attached the attributes to those entities. Now, is it forming some table-like structure? I want to convert product entity into a table. I can say, okay, in my product table, I have columns like product ID, product name, product category, and stuff like that, right? So this would actually give us a table-like structure. Now, products, in the products table now, we will have so many columns like product ID, and product ID it could be a data type of number maybe 10 digits, and we give some structure to that now. Since we have the information of entity and the attributes, product name, varchar 230, so on and so forth. This way, I can define what kind of information would be stored in those attributes, in each attribute. Right? In price, in product price, I might be storing decimal data. Price may be $10.99, right? So decimal. So this way I can define, okay, what are the entities, what are the attributes, and then I can give them a table-like structure. So this forms the tables within a warehouse. And then while designing the data warehouse, we try to denormalize the data instead of having the data in so many tables. We fetch the data from one or more tables into one data warehouse table. So in the OLTP, the required data might be in like 5 or 6 tables. Whatever the information for customer table in warehouse, I want to fetch the customer information, but the information related to customer itself might be in like 5 or 6 tables in the OLTP database. So what I will do is I will fetch the required columns from all those 5 or 6 tables from the OLTP database and load it into single table in the data warehouse. So that the only purpose here is to denormalize. Even though we denormalize the data, that doesn't matter. We need to reduce the number of tables. We're not bothered about whether the data will be repetitive, whether the values will be repetitive or not. We want to reduce the number of tables in the data warehouse so that the retrieval of data will be faster. Okay, so we do the dimensional modeling, and first we identify the client's business process, then we identify the entities of that business and attach attributes to those entities like this, and that gives us a table-like structure like what you call dimensions, we call them. We'll discuss about what is a dimension in fact later. And once we define all these entities and attributes, then comes into the picture like what are the things that you want to track in your sales. So in a sales transaction, I want to see what is the product ID, what is the customer ID, who purchased it, what is the location from where he purchased it, at what time he purchased it, or maybe put it as date, and through which channel he purchased it, and then comes into the picture, okay, what is the quantity he purchased, and what is the amount that we received with this. So now, in a sales table, you want to track these information. So if I say some product ID is 001, then if I want to know, and then quantity is, let's say, some 100, and amount is like, let's say, some 200, then what is product ID 001? How am I going to identify what is the product name of this product ID? Where do we have product name in this example?
Product table?
Yeah, so in the products table we have the product name. So usually I join this sales table with the product table based on the product ID and fetch the product name and then the quantity and amount that I want. Right? So this way, these are called business measures actually. So these business measures will be identified. What are all the business measures that that is required for the reporting purposes? So companies definitely want to know how much is the quantity that they are selling, how much is the total amount they got, and maybe they want to analyze more on what is the average quantity, average quantity sold, maximum amount sold, or median of quantity. So these are the different measures that they may want to calculate. They may want to know based on the sales data. Based on whatever the sales data they have, They want to analyze more like this. Okay, what is the total quantity, total amount, average quantity, maximum amount, median of quantity, so on and so forth. They will be requiring many measures to measure their business. So these measures, we keep them in a separate table. And we usually call these tables where we keep the measures as fact tables. And we usually call the entity tables as dimension tables. So we call location, dimension tables, and blah blah blah. We'll see what is a dimension and what is a fact. But just remember, wherever you see, first of all, when we start with the dimensional modeling, we identify the business process, and then we understand it thoroughly, and then we start with identifying the important entities in that business process. Like for sales process, the important entities are products, customers, locations, price, channels, promotions, etc. And then we are after identifying the entities, we attach the attributes to those entities. Attributes are the ones which describe more about a particular entity. And once we identify the attributes, we attach those attributes to those entities. And that forms a table-like structure, and we usually call them as dimension tables. And then we also identify the measures, business measures that are to be required by the client for the analysis purposes. And once we identify those business measures that they may want to see, we put them into a table usually called fact table. And fact table usually joins with the dimension tables based on these keys. For example, sales table. In the sales table we have a product ID. That would join with product ID of the products table. So this way the fact tables will be usually related to the dimension tables. We'll discuss about dimension and fact later, but then at least now I can say that when you do the data dimensional modeling, the output you get is some dimensions and fact tables that are going to be stored in the data warehouse. Those are also tables, but then we just call them as dimensions and facts for a purpose. And in a data warehouse, you can expect dimension tables and fact tables. So usually dimension tables will be having descriptive data like product ID, product name, etc. And fact tables will be having measures like total quantity, total amount, and stuff like that. And usually facts and dimensions are related to each other. Okay. So this way we can identify, okay,